Hi, my name is Abby Fearneyhough, and I was a member of the 2020 LIFT project cell phone group. I'm a mechanical engineering major, and my job was to research, help design the payload, and then analyze the data once we collected it. I did this along with Connor Hamp, who was a physics major, and then both Connor and I helped Kelsey Biggin carry out the lessons plans that she wrote for our work in the classroom. So we worked with Excel Academy in Casper, Wyoming, and we were lucky enough to be in person with them this year. We started out by posing the question, how high up in the atmosphere can your cell phone receive signal? We picked this project because we thought that it would be something that kids of all ages would be interested in because we did work with 3rd through 8th graders. The first couple of lessons we worked with them on learning about radio waves, specifically how radio waves can differ, and then how different landscapes and different weather and that kind of thing can affect how radio waves travel. We also wanted to teach them about circuits because most of our payload ended up being being electronics, and we did this using PhET simulations through the University of Colorado Boulder. This is a picture of an example circuit that some of the students could have created. This one includes a light bulb, a battery, and a resistor. And this is a really helpful tool because it's a really good virtual lab environment for students. They can change the voltage of the battery, they can change the resistance of both the light bulb and the resistor, and it just really helps them to picture how a circuit works. And they learned a lot about it, and I think that they had a better understanding of what our payload did because of this tool. So this is a picture of our actual payload. As you can see, it consists of an SD breakout board, a GPS breakout board, an Arduino Mega, a cell signal antenna, a 3G cellular breakout board, a GPS antenna, and a battery pack. It worked because we coded the Arduino Mega to direct the 3G cellular breakout board to collect data on the cell signal every 5 seconds. This data was sent to the SD card in the SD breakout board and just logged throughout the flight. And then we also coded the Arduino Mega to direct the GPS breakout board to record the location of the payload every 5 seconds. And this data was also sent to the SD card and the SD breakout board. This graph shows the results from our flight. So good cell signal is considered to be above -70 dBm. Fair cell signal is between -70 and -100 dBm, and then poor cell signal is less than 100 dBm. The graph is shaded to correspond with these values. When we first started our flight, we started at about 5,000 feet in altitude, and our starting cell signal was -62 dBm. And as you can see, most of the usable cell signal was lost by 30,000 feet. The most interesting part of this graph is definitely the rapid changes in cell signal. And most of this is due to the errors in our equipment. So a couple possible sources of error would be the direction of our antenna. So as the distance between the antenna and the cell tower increases, the importance of the cell antenna pointing directly at the cell tower becomes increasingly important. And this is really hard to do because of the winds in the atmosphere. So our payload was moving about pretty frequently, and the direction of the antenna obviously changed because of this. Another source of error could be the operating limitations of the Adafruit 3G cellular breakout board. We think that we were operating outside of its recommended distance. which would cause inaccuracies in our data. And in order to fix this, we would have needed more accurate equipment. And then I just wanted to include a couple pictures of us recovering the payload. It ended up landing pretty nicely in a pasture. And yeah, this is just us retrieving it. So that was our project for the 2020 school year.
So what would you have done differently? If you could do it all again, what would you do differently?
As far as like payload or just in general?
Or in general, yeah, either one or both.
I think we probably would have spent more time looking into the operating kind of limitations, I guess, of the equipment that we use. That wasn't something I think that crossed our mind when we first started this. And I think that we could have picked out better equipment if that was the case. And I don't know, I think like that's probably the biggest thing that I would change.
Awesome. Well, thank you again. And I will see you around then, probably on campus as everybody starts to get out more.
Yes, that would be good.